Okay, continuing with chapter 7. So in 7.5, we are talking about molar mass and how to do calculations with molar mass, all right? So as I explained in the last section, if you have 1 mole of an element, whatever that number that you see in the periodic table listed under the element, okay, it's that same number, but instead of the atomic mass units, it's in grams, all right? So if you had 1 atom of sodium, it would be 22.99 AMU, atomic mass units. But 1 mole of sodium, that means it's 6.02 times 10 power 23 atoms of sodium. They have a mass of 22.99 grams. So the mass of that 1 mole of element is its atomic mass, but it's expressed in gram, all right? 1 atom of carbon is 12.01 AMU, atomic mass units, but 1 mole of carbon is 12.01 grams. 1 mole of lithium is 6.941 grams, and you can use this as a conversion factor. All right. So basically look at the numbers under the elements in the periodic table. That's the molar mass. All right. So 1 mole of silver is 107.9 grams. Carbon is 12.01 grams. So if you are weighing out 12.01 grams of carbon, you're actually weighing out 6.02 times 10 power 23 atoms of carbon. That's how many atoms of carbon are in this 12.01 grams. 1 mole of sulfur is 32.07 grams. So in order to find out the molar mass of the compound, what we have to do is take the molar mass of each element in the subscript and then add up all of that, all right? Okay, multiply the mass of the element by its subscript and then add up every one of those results to get the final answer, which is the molar mass. Okay, so for example, lithium carbonate, there are 2 lithiums, all right? So that's 2 moles of lithium. So approximately about 7 grams of lithium per mole. So that would be 14 grams of lithium, all right? Carbon is around 12, all right? So 14 plus 12, and that would give you 26. And then you have 1 mole of oxygen is 16, but there are 3 of this. So 48, 26 plus 48, and that would be about 78 grams. So that would be the molar mass of lithium carbonate. Okay, so here you go, 2 moles of lithium, that's about 13.88 grams, approximately 14. And then 1 mole of carbon is 12 grams, and then 3 moles of oxygen is 48 grams. And you add these all up together, okay? So I got it slightly wrong. So 73.89 grams of lithium carbonate, okay? So that's how you obtain the molar mass of any compound, whether ionic or molecular. So to get a visual of mole quantities, all right, this is 32 grams of sulfur, that's a mole. This is 56 grams of iron, that's a mole. 58 grams of NaCl, that's a mole of NaCl, and so on, okay? 294, all right? So you see the quantity is so high. That's a mole of the potassium dichromate. And then sucrose, table sugar, 1 mole is 342 grams. So you see the mole quantities for different things are different, all right? Here for these elements, they're very small amounts, whereas you see the molecular compound like sucrose, it's so high. So it says calculate the molar mass of C2H6O, okay? So add up their individual elemental molar masses and add it up to get the molar mass of the compound. So there's 2 moles of carbon, so that's around 24, 6 moles of hydrogen, that's around 6, so 30, and then you're adding 16 for 1 mole of O, so about 46. All right, so 1 mole of methane is 16.05, all right, 12 carbon and 4 for hydrogen, okay? So you can use that as a conversion factor, 1 mole over the molar mass and a molar mass by 1 mole. So if you want to convert grams to moles, then you will use the moles over molar mass, and then if you want to convert moles to grams, then you will use the moles times the molar mass. So you're converting 737 grams of NaCl. How many moles? So take the molar mass of NaCl, 58.45, and divide 737 by the 58.45, and you should get the moles of NaCl. Okay, so 58.44 grams of NaCl. Using that as a conversion factor, you want to get rid of grams, so you'll multiply it by this conversion factor, 1 mole over molar mass. Okay, and so you divide this by this number and you get 12.6 moles of NaCl. So a sample of water is 59.8 grams of water. So molar mass of water is 18.02. So divide the 59.8 by 18.02 and you will get your moles. So 3.32 moles of water. Alright, so this is called as a mole map. Some people call it mole island. It's the same principle like going island hopping. What is the best path to take? If you're converting grams of an element like aluminum, sulfur, or hydrogen gas, oxygen gas, then if you're going to convert it into moles, grams to moles, then you divide by the molar mass. All right, okay. But if you're converting moles to grams, then you multiply by the molar mass, all right? Moles is a small number. Grams is going to be a larger number, all right? So when you're converting the smaller number to a larger number, you're multiplying. When you're converting a large number to a small number, you divide, okay? Again, moles to the number of atoms, you multiply by Avogadro's number. Small number to large, multiply, all right? Large number to small, you divide. So here, if you have number of atoms, then you're dividing by Avogadro number to get moles, okay? If you want to know what the moles of the compound is, look at the formula subscripts and add the individual moles of the element making the compound to get the moles of compound. Again, if you want to know what the number of atoms in a molecule is, again, look at the formula subscripts and that will tell you the number of molecules or formula units in an ionic compound. So if you have moles of compound and you're converting it into grams of compound, then the same principle. You multiply the moles by molar mass to give you grams. If you have grams, then divide by the molar mass to get moles. All right, the same principle. Going from large to small, divide. Going from small to large, multiply. All right. Same thing here. You multiply by Avogadro's number to get the number of molecules. You divide the number of molecules or formula units by Avogadro number to get moles. And we'll stop here.